For example, we have a coin which is tossed 1000 times. So the number of trials is 1000 times, and these are the frequencies: head 45, 455. So this is the probability of head. Tail 545. This is the number of trials in which the event occurred is 545. Total number of trials are 1000. So this is the probability of head. This is the probability of tail. So total probability of E, total number of heads by total number of trials, 455 by 1000, that is 0.455, and the probability of getting the event of getting a tail is number of tail by total number of tails. This is 545 by 1000, that is 0.545. If you add these two, you will get 1. So probability of getting head and probability of getting tail, they will add up to 1, and this is very important because E and F are the only two possible outcomes of each trial. So when you add them, it has to come 1. The probability varies from 0, that is in all the trial, none of the trial has that event occurring, that is that event never occurred in that trials, which is 0, and every time you did the trial, or at that trial every trial, that event has come up, so the probability will be 1. So probability varies from 0 to 1. You will find the values always between 0 to 1. So two coins are tossed simultaneously 500 times, and we get two heads 105 times, one head 275 times, no head 120 times. Find the probability of occurrence of each of these events. So this is 105 by 500. This is the probability of first event. 275 by 500, second event. 120 by 500, three event. E1, E2, E3. And if you add these two, P1, PE1, PE2, PE3, that will be going to be 1, because E1, E2, E3, they cover all the outcomes possible of a trial here in this example. A die is thrown 1000 times with the frequency for the outcome 1, 2, 3, 4, 5, 6 in this table. So the outcome is 1 to 6 and the frequency is this. So we have to find the probability of getting each outcome. So how to get this? We know that the probability of outcome of 1 is the frequency divided by the total number of trials. So 179 divided by 1000. Similarly, for this second one, getting 2 is 150 by 1000, getting 3 is 157 by 1000, 149 by 1000 for 4, 175 by 1000 for 5, 194 by 1000 for 6. So this is all you get. P6 190 by 1000, just add all of these, you get 1. So the probability of each event will lie between 0 to 1. If you are getting below 0 or above 1, that means there is some error we need to rectify. Then sum of all the probabilities of all the possible events which are being said for an experiment, they must add up to 1. E1 to E6 cover all the possible outcomes of a trial. Now we have an example. On one page of telephone directory, there were 200 telephone numbers. The frequency distribution of their unit place digit, for example this, where unit place is 3, is given like this. Getting a 0 here is 22, 1, 26 like this. So without looking the page, the pencil is placed on one of these number and the number is chosen at random. What is the probability that the digit in its unit place is 6? So this is 6. We need to find out for 6. Let us go to 6. This is 14 by 200. So we have 14. The frequency of 6 is 14 in the table. The total number of selected telephone numbers are 200 as given in the question. So 14 by 200, that is the event, or you can say the favorable number of times that the trial has got an event, and this is the total number of trials being done. 14 by 200, that is 0.07. This comes between 0 to 1. So this is correct. The record of a weather station shows that out of the past 250 consecutive days, its weather forecast were correct 175 times. What is the probability that on a given day it was correct? So the total number of days for which the record is available is 250, right? Its weather forecast were correct 175 times. So the forecast was correct on a given day, that is 175 by 250, that is 0.7. Now the total number you can also find out in similar way. You don't have to go to the second one. I'll tell you how. You have to find out what is the probability that it was not correct on a given day. So we have correct and this P not correct, NC, let me write P not correct is simply 1 minus this one, P correct, right? So we have this as answer as 0.7. So 1 minus 0.7 is, this is the correct one, and 1 minus 0.7 is for non-correct. So 0.3 is the not correct forecast. But we'll do in some other way also. See, 250 is total, correct is 175, subtract them, you get 75. This is the incorrect one. So 75 by 250 is the probability that the forecast was not correct on a given day. If you add them, 0.7, 0.3, you'll get 1. A tire manufacturing company kept a record of the distance covered before a tire needed to be replaced. This table shows the result of 1000 cases. So the distance which is less than 4000, 4000 to 9000 like this, these are the frequency. If you buy a tire of this company, what is the probability that it will need to be replaced before it has covered 4000? So this is 20 by the number, which is I'll tell you 20 by this 1000 will be the answer of this. I'll tell you one by one. Let us get some rough idea now. It will last more than 9000. So 9000, more than 9000 means this. So 325 plus 445 divided by 1000. Then it will need to be replaced after it has covered somewhere between 4000 and 14000, like this. So 210 plus 325 divided by 1000 is the answer. So total number of trials is 1000. The frequency of tire that needs to be replaced before it covers 4000 km, as you just saw in the table, is 20. 20 by 1000 is 0.02. Now the frequency of tire, second one, that it will last more than 9000 is 325 plus 445, and the frequency of a tire that requires replacement between 4000 and 14000 is 210 plus 325. That means we are talking about 9000 and 4000, and we are talking about 4000 and between 14000, right? So when you add this, you get, first one, let us take 770. So 770 by 1000 is 0.77, and 535 by 1000 is 0.525. The percentage of mark obtained by a student in the monthly unit test is given like this. Based on this data, find the probability that the student gets more than 70% mark in a unit test. So 70%, more than 70%. That is, we have to choose scoring 70, this 1, 2, 3, 4. So the number of unit tests in which he scored more than 70% marks is, you see here, total number of unit tests is 5, and total unit test where he scored more than 70 is 1, 2 and 3, because 69 and 68 are below 70. So 71, 73, 74, so there are 3 possibilities or 3 event or trial where the event has occurred or can occur. And what are the number of tests? 4 or 5 total. So 3 by 5 is the probability, 0.6. An insurance company selected 2000 drivers at random without any preference of one driver over another in a particular city to find a relationship between age and accidents. The data obtained are given like this. So we have age 18 to 29, and the accidents in 1 year 0, 1, 2, 3 over 3 are like this, right? So 18 to 29, the accidents in 1 year 2, that the number is 110. Above 50, these are the numbers over 3. So they above 50 over 3, there are only 9 accidents which are being done. So find the probabilities of following events for a driver chosen at random from the city. Being 18 to 29 years of age and having exactly 3 years in 1 year. So 18 to 29 and exactly 3. So these are 61, right? 61 divided by 2000. So this becomes 61 divided by 2000. This is the probability. Being 30 to 50 years of age and having 1 or more accident in a year. 30 to 50 and having more than 1 or more accident, 1 or more. So we'll take this. All this we have to add. 125 plus 60 plus 22 plus 18. So we have to add 125, 60, 22, 18 we have to add, because this is over, means 1 or more. So we have to get 225. This is the number which is the favorable cases, or you can say the event occurred in this trials, and these are the number of trials, or these are the number of the cases total, which is 0.113. Now the third one is having no accident in 1 year. So no accident in 1 year, 0. That means 0 accident. So all these have to be taken care. So 440, 505, 360 we have to add. This is 1305 by 2000. This is 0.653. Consider the frequency table. We'll see the frequency table and just assume that we have already seen that frequency table. I'll just explain you, which gives a weight of 38 students of a class. Find the probability that the weight of a student in the class lie in the interval 46 to 50. So the total number of students 38, and the number of students with weight in the interval 46 to 50, if we assume it to be 3, so 3 by 38 is the answer, that is 0.079. Given two events in this context, one having probability 0, another having probability 1. So the simple answer would be an event that the student weighs 30 kg. This is, since no student has this weight, the probability of occurrence of this event will be 0. And the probability of student weighing more than 30 kg, because there is no student which is having, there are all students which are having 30 kg and more. So 38 by 38, this will be 1. 50 seeds were selected at random from each of 5 bags of seeds and were kept under standardized condition favorable to germination. Now after 20 days, the number of seeds which had germinated in each collection were counted and recorded like this in the table. So we have bag 1, 2, 3 to 5, and number of seeds which are being germinated are given like this. So let us see what question are being asked. First is, what is the probability of germination of more than 40 seeds in a bag? So more than 40 seeds in a bag, more than 40, so 48, 42 and 41. This we are going to take because we are being talked about more than 50. So we have 3 of them. So 3 divided by 5, total of 5. 49 seeds in a bag. 49 seeds in a bag. Let us see 49. 49 seeds in a bag. So we have no number as 49. So 0 by 5, 0. And then more than 35 seeds in a bag. All of them are having more than 35. So just add all of them. And these are 5 basically. You don't have to add. They all are 5 because all are more than this. Divided by 5, that is 1. So this is the probability of getting 0 and 1.